Okay, everyone, welcome to this video lesson. This video lesson specifically called Work Word Problems Part 2, right? Work Word Problems Part 2. So make sure you're taking notes, paying attention as we go through this lesson together, right? So just like Word Problems Part 1, these notes may look familiar, but this lesson will deviate just a tad bit different. Right? So what we do know is here, like antenna number 1 says, is that one person's work plus another person's work is their work together, right? And we talked about this, so that we already know. Our second antenna is how would working together affect the total time that it takes to do one particular job, right? So this is what we are going to look at. Now, the formula that we're going to use, or the tool that we're going to use, is this right here. Right? And as we remember, we say 1 over T1 plus 1 over T2 equals 1 over T3. Right? Now, we know that, right? We know that T1 is time taken by the first person. T2 is time taken by the second person. And T3 is time taken by both or together, right? So this is the idea that we're going to use. We're going to be using this right here to set up all our equations. So let us look at the instructions first. Always look at the instructions first, right? We must always read the instructions first before beginning our assignment. So our instructions say solve each question, right? And we're going to round answer to the nearest hundredth place. Okay? So let us read our first example here. So it says, working together, Alberto and Sarah Wong can clean the inside of a school bus in 98.13 minutes. So working together, they can clean it in 98.13 minutes. Okay, let's continue. Had he done it alone, it would have taken Sarah Wong 199 minutes. So Sarah Wong did it in 199 minutes had he been working alone, right? So we're going to find out how long it would have taken Alberto to do the work alone. So Alberto alone, right? How long would it have taken Alberto to do the work alone? So as always, we set up our two main people involved, which is Alberto and Sarah Wong, right? And then we found out how long it takes them to do the work together. So let's see, Alberto. Alberto says, find out how long it would have taken Alberto to do the work alone. We have no idea, kiddos. So that's X. We don't know. Okay. Sarah Wong says 199 minutes, so I'm going to put 199 here. And together, it said it was 98.13 minutes. 98.13. Now, we're going to use our 1 over T1 plus 1 over T2 equals 1 over T3, right? So 1 over T1 is time 1, which is Alberto, which is X, plus 1 over time 2, which is Sarah Wong, which is 199 minutes, and 1 over T3, which is the time together, is 98.13 minutes, right? Now, we remember that our next step is we're going to multiply X times 199 times 98.13. So on the side here, I'm going to say 199 times 98.13 times X. So these two give me 199 times 98.13. So let us use our Desmos calculator. So we say again, let's see, 199 times 98.13, 199 times 98.13 is 19,527.87, right? 19,527.87. 19,527.87, right? Yep. And you see this x right here? This x just comes down like that. So this is what we're going to multiply here, right? This is what we're multiplying by each one of these ones. Now, fortunately, we know that what 19527.87x times 1 is, it's going to be the same thing, right? So all we're going to do is we're going to multiply that times 1. It's going to be the same thing. That times that one is going to be the same thing. And that times that one is going to be the same thing. So 19527.87x over x plus 19527.87, oops, 0.87x over 199, I forgot the 7 here, equals 19527.87x over 98.13. Now, you may be wondering, these are large numbers to multiply and divide, right? Well, first of all, the easy part here goes here because this x is going to cancel with this x. So this x cancels this x. So then this just comes down by itself. So we get 19527.87 by itself. Look at that. Plus. Now, the idea is dividing these two. Now, if we remembered, right, these two numbers multiplied to give us this one, right? So if I go backwards, that divided by 199, it equals to 98.13. So this divided by that number is 98.13. Now I can't forget the x. X comes down. Equals, same idea here, right? 19527.87 divided by 98.13 will give us 199. So these two equals 199, and I can't forget my x. My x comes down. Now I'm going to draw my line of separation. This x needs to be with this x. So I'm going to move it over here, but when I move it over, it subtracts. So minus 98.13. So x. So I have 19527.87 here on the left. And 199 minus 98.13, let's see. 199 minus 98.13 is equal to 100.87. So I get 100.87x. And what is happening between here, 100 and x, remember there's an invisible point here, which means multiply. So the opposite of multiplying by 100.87 is dividing by 100.87. So now what comes down here is just my x, right? So my x comes down here. Now, what is this? Let's see. 19527.87 divided by 100.87 is 193,594. 193.594. We are rounding to the nearest hundredth place. The nearest hundredth place is, oops, go a little thinner here. The nearest hundredth place is this 9 here, right? Which means that the 4 is going to tell the 9 what to do, right? So since it's 4 or less, let it rest, right? 4 or less, let's let the 9 rest. So 193.59 is equal to x. Now, numbers-wise, this is our solution, right? But this is a word problem, so we need to write this in a word statement. So the question said, how long would it take Alberto to do it alone? So you would say, it would take Alberto 193.59, is it hours or minutes? Minutes. Minutes to do the work alone. There you go. Look at that. This is our final solution right here, right? Because remember, this is a word problem, so we need a word answer. And there we go. Look at that. Now, I'm sure many of you have spotted shortcuts, right? So we need to spot those shortcuts and see what we can do with them. Okay, let's see what we can do with those shortcuts. All right. So let us go to our second problem here, and we'll be referring back to our first problem to see what we can spot. See what we can spot our second problem here. Okay, so our example here says, let us change some colors here. Go with that. Let's see. A Basra can shuck a bushel of oysters in 152.3 hours. So a Basra can shuck some oysters in 152.3 hours. Okay. One day her friend Castell helped her, and it only took 86.18 hours. So, right? One day her friend Castell helped her, and it only took 86.18 hours. So they worked together and did it in 86.18 hours. Find how long it would take Castell to do it alone. So Castell alone. We need to find out. So let's see the two people involved in this problem. So we have a Basra, we have Castell, and we have together, right? So a Basra can do it in 152.3 hours. Castell, we don't know how long it would take him to do it alone. And together, it says they would do it in 86.18 hours. 86.18 hours. Right? Look at that. So, let us take a look here and what we did. Okay, so we used our formula, which is 1 over T1 plus 1 over T2 is equal to 1 over T3. So let's do that. Right? 1 over time 1, you know? But you know what? If you want to get ahead of things, let's do this. So we know that we multiplied all three denominators here. Look at that. And we got this answer. And that was the tops of all of these fractions here. So why don't we do a little shortcut and let's multiply these three here to get the top of our equations, of our fractions, excuse me. So we're going to say 152.3 times 86.18 times x. So what do we get from these two? 152.3 times 86.18. 152.3 times 86.18 is 13,125.214. Okay? 13,125.214. So that's going to be the top of our x. I can't forget x. You know what? Let me 214 x. So that's going to be the top of our 131.214x is equal to, let me make this a little smaller because it doesn't fit here. Okay, is equal to 131.25.214x. Right, there you go. So time 1 was 152.3. Time 2 is x. Time 3 is 86.18. Look at that. Right? So just like we did before, right? So this number divided by that number, right? So let's go backwards. This number divided by that number will give us 86.18, right? So that divided by that is 86.18x, right? This x must come down. Nothing happened to it. Now, the x on this one, on the other hand, cancels out. This x cancels with this x. So we just bring down 131.25.214 is equal to that divided by that. So let's go backwards. That divided by that will give us 152.3. 152.3, we must bring down the x, right? That divided by that, 152.3, the x must come down. So we must move this x over here to this x. So let us cross it out. Right? And bring it over as minus 86.18x. Right? So let us subtract these two. 152.3 minus 86.18. 152.3 minus, minus 86.18. 66.12. So we get 66.12x. Don't forget we still have that x. And here we have 131.25.214. All right. So now we must get x by itself. So the opposite of multiplying here is dividing on this side, 66.12. And now let us divide these two. Right? Let us divide these two. 131.25.214. 131.25.214 divided by 66.12. And get 198,505. So we get 198.505 is equal to x. Right? We remember that 0 is the hundredths place, so that means that the 5 is going to tell the 0 what to do. Right? What are we going to do? Is it 4 or less? 5 is not 4 or less. Right? 5 or more, add 1 more. So we're going to add 1 more to 0, which is 1. So we get 198.51 is equal to x. There we go. So let us write our statement here. So the question was, how long would it take Castell to do the work alone? Right? It would take Castell 198.51 hours to do the work alone. And that is your solution for that one. Right? There you go. So we use a little bit of a shortcut here on the second example, but that right there, kiddos, is how we do this assignment. So make sure you took some good notes, you paid attention. Thank you guys for being here, and see you next time.